Welcome back. I have Selena here with me for another great area lesson. We've been doing so much area work that today we're going to kind of wrap up area, and we're going to be talking about area of a pentagon, and that's going to lead us into area of other polygons. And I can't wait to get started. So here is our pentagon. It is from the metal material, just like where we had the rhombus and trapezoid work. So it's a flat one. And so we're going to be trying to find the area of this pentagon. When we look at the pentagon, we look at that and we're like, gosh, I'm really not sure how I'm going to make that into a rectangle, because we know making things into rectangles is how we find the area the easiest way. So I have a divided pentagon here. Pentagon, remember, is a five-sided figure. So before we get started taking it apart, though, I want to talk about or review the parts of a polygon. And maybe one of these parts might be new. I can't remember when we talked about this last. So when we talked about the parts of a polygon, we have this part here. What is this called? The base. The base. And what are these other parts called? The sides. And what is this point? The points that it turns on? The vertices. Vertices, or a vertex. Many of them make vertices. Yeah. Okay. And then some of the area is the space inside, or the space that it takes up. Okay. And the little handle on here is the center. Now these are two parts that you may not have heard. Oh, I left off one you have heard, but here's two that you might not have heard. When you draw a line from the vertices, or any of the vertices, to the center, from here to here, those make a radius, just like a circle. The circle is a radius from the outside of the circle to the center point. The radius is found from the vertices of a polygon. So from here to there, that's a radius, and that's a radius, and that's a radius. So this divided one is divided on the radius. And then the other one that you may not have heard is when we talk about from the center to the base. The center to the base would come down right straight through that triangle right to the bottom here. That length from the center to the base in the center is called the apothem. Apothem. And so those are maybe the two new ones that you will know or need to know. So let me go ahead and write apothem. It's a hard one to think about because it's kind of funny. Can you say that there is one that we already knew that you forgot to say? Yes, thank you. I pointed at it as we talked about the outside edge. What are these called? The sides. What happens when we add all the sides up? What do we get? The perimeter. Yeah, so we talked about that one. That's part of your work. So the apothem, I'm going to put in, I cut a little piece, the sticky note there. The line that comes down the center, oh, you can't really see that on the camera. The line that comes down the center right there is called the apothem. And the radius is the line that's created from the center to a vertex. Okay. Now that we've reviewed our parts of our polygon, or learned some new ones if you didn't already know them, now we're going to work on what we talked about, finding the area by turning this into a rectangle. Selena, can you build me a rectangle with those pieces? I'm going to slide this out of the way so we can move this up a little higher. Okay, you did not build a rectangle. What did you build? Trapezoid. A trapezoid. You built a trapezoid. So we do know how to find the area of a trapezoid, but that doesn't make this any easier, really. So what we need to do is we need to figure out how to make this into a rectangle. It would be really nice if we could take this piece right here and break it in half, and we'll glue the other side on the other end. Wouldn't that be nice if we could do that? Well, when we were talking about the apothem in our frame, and I said I had these two little pieces that I had cut, like that, you can see that they're so close in color. They really aren't in real life. But you can see that I have cut this piece of paper. I'm trying to get the right shot. Oh, there we go. I've cut these two pieces of paper, and they are half of one of these pieces. Oh, it's stuck. There they are. They're half. So if we take this piece off and put one of those on each end, what do we have? A rectangle. We've created a rectangle. That one's a little bit curved. Now we have a rectangle, which we could find the area of. So we know how to find the area of rectangle. So when we are looking at this, we need to figure out what we always need to figure out. Sorry, I'm just going to straighten it up because it's crooked and it's bothering me. There we go. Okay, so when we talk about this, we can talk about what parts made what. So when we look at what parts made our pentagon, what part is making the base of our rectangle? The perimeter. Is the perimeter the whole bottom here? No. If it was, it would have to be like this, and it'd have to be end to end, right? It'd have to be like that, but that's not what we have. So it's half the perimeter. Let's see, we have one side, two sides, and half of a side. And then on this side we have 1, 2, and a half. Yeah. The base is half of the perimeter. Let me get some tickets to write that on. So the perimeter, the base of this, is our perimeter divided by 2, makes our base. And what makes our height? What is that distance there? It's not the side, and it's not the radius. Apothem, is that how you say it? Yep, apothem. The apothem was the distance. The apothem is the distance from the center of our figure to the base. So if we're looking at our base is made of half of the perimeter, and our height is made by the apothem. Okay, so let's write down our formula here. The the area of our pentagon is equal to our perimeter divided by 2 times our apothem. So let's see if we can measure this. Let's go ahead and find the area of this pentagon. Can you find, in centimeters, can you find the length of, we can do just one of the sides? 6. So what if this side is 6? So we have 6 plus 6 plus 6 plus 6 plus 6, or 6 times 5, 30. So our perimeter is 30. And what is our apothem? You can measure it off of here since they're already cut. The camera says no. There you go. Looks like 4. 4. Okay, what is 30 divided by 2? 15. 15 times 4 is our apothem. 15 times 4. 15 times 2 is 30. So 15 times 4 would be 60. 60 centimeters squared. The area of this pentagon is 60 square centimeters. Pretty cool. Now you can find the area of any pentagon you want. You can draw them yourself. You can find, I don't know if you can find pentagons in the environment. Where would we find pentagons? It's an interesting question.